I think it's one of the most interesting findings in the last century. And I don't know exactly what it points towards. I hope you can help, elucidate, make clear what it does today and what your methodology was. But you detected through this synthetic aperture radar Doppler tomography, this really exciting new technique, what seems to be like it looks like an energy grid below the Khafra pyramid on the Giza plateau. And there's a lot of controversy. You have Zahi Hawass, who's this cultural, minister of culture there, former minister of culture, and he says, it's fake news and there's nothing there. And then you have a lot of people supporting you, saying that there actually probably is something underground. Obviously, that whole area is full of subterranean chambers. So it's an honor to speak with you today. I'm very
Thank you very
excited
much.
to get to the bottom of this here in beautiful Perugia, Italy.
Thank you very much. Yes, thank you for saying me that we made a very great discovery in Giza. Just to begin, the work was done together with Corrado Malanga, who is the head of the research group, Armando May, and me. I am the technician that developed this synthetic aperture technique, and I shared it to the group, to everyone, and so to perform the scanning at the Giza plateau.
I want to start with the most to the point question, and then we can back up and figure out how we got there. What, in your opinion, say a gun was to your head, you had to just guess. What do you think is underneath the Khafra pyramid?
Okay. Yes. Thank you for this question. The answer is a bit difficult for me to give you an answer, a precise answer, because the truth, we will know the truth only if we go inside physically there to check what there is exactly. Now, what we can say that we have measurements, physical measurements that are acoustic measurements, and we performed these measurements, as you announced before, using a synthetic aperture radar. Then we will speak about the synthetic aperture radar and how we arrived to perform these measurements. We are considering tomographic analysis on, first of all, we began this analysis on the Great Pyramid of Cheops, and then we moved on the Khafre Pyramid, and then extending all the measurements on all the Giza plateau. So what we are watching? We are watching huge structures that are connected to the base of the Khafre pyramid, and these structures are extending underneath for, let's say, tens and tens of meters. Approximately, we have measured approximately over 1 kilometer of depth.
Over a kilometer of depth?
Over depth, yeah.
Wow.
Yeah.
So over 1,000 meters. And what do the structures look like?
Yes, the structures are like that. The tomographies are public, so we have done a scientific interpretation of those tomographies, and they are like tubes that are connected to the base of the pyramid. We are counting at the moment 4 plus 4 tubes that are descending underneath, and they are connecting the top, so the base of the pyramid, to something that is located at the bottom. So at the bottom, we probably have huge chambers for approximately 80 meters wide, of width, and also of height, 80 meters.
Wow.
On the bottom.
On the bottom?
Yes.
And so what is that? That's like the kind of foundation structure on which the tubes are coming out.
Probably because we are observing that the tubes are connected to the respective top of this structure. They are connected and goes inside.
Wow.
Also. Because then I explain you why and all the physics that is behind all these measurements. And obviously, we don't know the exact objective of these things. What we know now is this: there are these structures, tubes, huge tubes that are descending underneath, and we have noticed that these tubes has a sort of spiral nature.
Mm.
Mm? So they spirals around their self, going down. And then we have noticed that each tube has a core in the center, which is let's say, connects the spirals,
Mm-hmm.
no? And this core descends down. So, just to be clear, the physics behind all this work that we have done. We have used an equipment or a device, let's say a device, a payload that is called a radar. Radar is an acronym that it means radio detection and ranging. So we detect things remotely, and while we detect things, we can also measure a distance. This is radar. In the past, radar was installed on board ships, maybe to know for safety navigation or on board aeroplanes. But today, they are also on board satellites. And of course, technology advanced and radar became synthetic aperture radar. Why synthetic aperture radar? Because we need to perform pictures, electromagnetic pictures of the Earth. It recasts in the so-called remote sensing of the Earth, so Earth observation. And the more the aperture and the detailed are the image of the radar. So synthetic aperture radar, it means that we synthesize a very long aperture in order to have very high resolution on the Earth. We are talking about submetric resolution. Maybe a pixel can be of this dimension of this square that is on the floor. So it is very important.
Yeah, it's like a quarter of a meter, right? Or yeah. It's pretty strong resolution. And there are companies like ICEYE and others that do all sorts of work when it comes to synthetic aperture radar. They have, Umbra, Capella Space, which I think are responsible for some of these scans, are very credible companies that do work in defense and commercial applications as well.
Yes.
Okay.
There are the companies that you said. They are American, Capella Space, and also ICEYE is an European company. We have Cosmos Skymed and Cosmos Skymed second generation, which is an Italian company affiliated to the Italian Space Agency. So we have a lot of equipments, a lot of radars, and we use the data produced by these satellites to perform the scanning on Giza.
And so radar, backing up, is just bouncing radio waves off of physical objects.
Yes.
Synthetic aperture radar is a way to do that with finer resolution, essentially. And so how does that work exactly?
Yes. I have to tell you this that is very important, because initially when we announced this discovery, there was a lot of mess in terms of scientific information. So misunderstanding, a lot of misunderstanding. Radar, synthetic aperture radar cannot penetrate the Earth. So electromagnetic waves has only superficial interaction. According to the Maxwell theory, according to the past physics, classical physics, the interaction of electromagnetic wave is superficial. Maybe you can have a bit of penetration, but very, very few centimeters of penetration. in this case, we have developed a new technique which we are able to detect the superficial vibrations of the Earth.
Mm.
Why? Because vibrations penetrates the Earth. It means that photon and phonons, which is the quantum of light, of electromagnetic waves, and the quantum of vibrations, so photon and phonons, are separated by something called boundary.
Mm.
It means that light propagates only in the free space and not in the matter. Phonon propagates only in the matter and not in a free space.
Mm.
So, in order to combine these two, we tried and we successfully combined the two informations given by the photon and by the photon. Where we have both of them? Try to guess where we have both of them. In the intersection.
At the boundary.
And at the boundary, we have the information of the photons and the phonons. We have the interaction of them. And there we were able to retrieve the so-called sufficient statistic in order to perform tomographic inversion and so to go deeply inside the Earth. So this is something that we have developed 2 years ago, and it is new. And at the beginning, people were not, was something new. So it had to pass some time in order to realize that this was possible.
Is something penetrating the Earth? So in the case of radar, like you said, it's reflecting off the Earth's surface, pretty much superficial. What else is penetrating the Earth to even gather the data on the structures?
I tell you this: the satellites flies in the space on a velocity of approximately 7 kilometers per second. It means that in 1 second the satellite has flow 7 kilometers. Then this high speed, this high velocity permits the radar to synthesize a very generous Doppler bandwidth. Doppler, it means that the electromagnetic waves that we transmit and receive are frequency modulated by the movement of the Earth. Okay? If the Earth vibrates because of the presence of seismic waves, the presence of vibration due by the cities, the presence of vibration due by any natural phenomena occurring on the Earth while we are observing it by the radar, it means that the Earth is moving. And if this movement performs a frequency modulation on the returned signal.
Yep.
So this frequency modulation is proportional to the vibration.
Yep.
So we can grab the vibration of the Earth. And this vibration that is located on the boundary has all the information of the vibration present below the Earth. According to this, it was possible to perform an algorithm that realizes tomography. Tomography, it means I look inside. Tomos in Latin, it means slice. Okay? So we can scan the Earth according to slices that are located below the Earth. The slice, imagine to uncharge or to extract a vibrational slice from below the Earth, and here you can see everything concerning the energy vibration on a certain depth.